Parallelograms area lesson, triangles and parallelograms.
We'll start with the schema we should have from previous grades. Number one, that while area and perimeter are both measurements, perimeter is one-dimensional, simply a length, area is 2D. The definition of area being the number of square units needed to cover a surface, and therefore is measured in units squared. We talked about how we can use formulas. First in grade 5, it's related to algebra, because it uses letters, and it will save us time. When in doubt, we count squares, but as grade 6, with shapes we know, we apply a formula. Like for example, length times width equals area was a formula you learned for rectangles in grade 5. Or we can learn a new one. So today we talked about 3 key words. The first, perpendicular, opposite of parallel, when two lines meet at exactly 90 degrees. We learned about the word base, which is simply a line that could apply to any side, but generally the one at the bottom, like base of a mountain or basement, means bottom. And the height, the distance formed using a perpendicular line from the base. So they form that upside down letter T. So first we applied that to the rectangle I gave you, which you'll remember was 10 by 6. So for perimeter, we could add up the sides, and for area, we hopefully could apply a formula. Now if you want to try something a little more advanced than simply adding up the sides, you can apply a formula for rectangle perimeter. Not every shape, rectangles and parallelograms. Since they have 2 lengths and 2 widths that are equal, you can add 1 length and a width and then double it to account for the other side. So in our case, it was 10 and 6 to make 16 times 2 equals 32 units. Now quite simply, to solve the area of this rectangle, we start with the formula. You can see it on the picture. A equals B times H. Then we substitute 10 for B because the base was 10. And we substitute 6 for H because on our rectangle the height was 6. 10 times 6 gets you 60, and remember it's units squared. Now it's time for the heavy lifting. Our learning target was to create an area formula for triangles and parallelograms that was based on our understanding of rectangles. So of course we began by taking our 10 by 6 rectangle and making one straight line slice from corner to diagonal corner. Now you've got 2 triangles and your task was to create a parallelogram. Then to solve the area of that parallelogram before considering the new dimensions and using them to create a formula. Well, as most of you realized, whether you created this parallelogram, where the 2 sides that were 6 units long were connected, or if you made the one where the 2 10-unit long sides were connected, either way, parallelogram. Based on the feedback I got in class, it seemed like everyone understood that we simply rearranged the same 60 squared units, so this was the exact same size as our original rectangle. What I was hoping we'd all realize, at least eventually, was that now we can't simply multiply the base of 10 by that width, the diagonal line where it says who cares, because that's much longer than 6. And 10 times that number would give us a product way bigger than 60. So what we need to realize, of course, is the 6 we need to multiply the 10 by is there in the middle, where the H for height is. It's a 90-degree perpendicular line from the base, as you can see here on the definition of height from earlier in the lesson. Here it is one more time. Height, a distance formed using a perpendicular line from the base to the top of the shape. So in this case, it doesn't matter how slanted the parallelogram appears to be. All we need to worry about is a straight line that makes a 90-degree angle from the bottom to the top. Now we've got to apply that base and height understanding to a new shape, the triangle. So we took our triangle, or one of them, threw the other away, and immediately realized, hey, this is exactly half as big as the original rectangle, or the parallelogram I just made. So if those two were 60, this one's got to be, drumroll please, 30. So our first expectation, solve the area, done. Now we have to figure out how do these dimensions work in order to come up with a formula we can use for every triangle from now on. Well, the base is still going to be 10 and the height is still 6. You'll notice on mine it's flipped the other way, but same difference. So if 10 times 6 is 60, how do we turn that into only 30? Obvious answer, let's divide it by 2. So at the end of the day, we now have a formula for triangles. Base times height divided by 2. When we substitute in 6 and 10 for the base and height, we leave the divided by 2 part. Now I start simplifying. I don't have to do all that math at once, so you can see line 3 is just 6 times 10, 60, divided by 2. Then I get area equals 30 units squared. So here's your recap. Here are the formulas that hopefully you can now apply. For perimeter of any parallelogram, in brackets, add the length and width first, then times 2. For parallelogram area, we do area equals base times height. Remember, rectangles are a type of parallelogram, so you don't have to do length times width anymore. And for triangle area, base times height divided by 2. Seacrest out.